A car moving along a low road increases its speed uniformly from 16 meters per second to 32 meters per second in 10 seconds. What is the car's acceleration? What is its average speed? How far did it move while accelerating? So, we know the 16, that is going to be the VI. Some of you like to write it out. Some of you just like to write VI beside the 16. Whatever works for you is good. That makes the VF equal to 32. The time, or the change in time, I guess you could say, technically is 10 seconds. And we are asked to find the acceleration. Which one of the special formulas from yesterday has VF, VI, and AT in it? VF equals VI plus AT, the first one, exactly. So let's just go ahead and use that. Now, you might say, can't we just use the grade 11 ones? Oh, sure you can. You can also go back to pumping water by hand and washing your clothes down by the river, too, if you want. But let's step into the 21st century. Yes. Yeah, I kind of wish you'd done it earlier. VF equals VI plus AT. So the VF is our 32. Our VI is 16. We're solving for A, and our time is 10. Now, advanced students of mathematics, such as yourselves, should probably be able to solve that. Not necessarily do the math in your head, but you should be able to do the steps in your head. Right? You should know that the first step is to get rid of the 10 by divide. Hang on, I'm wrong. The first step is to get rid of the 16 by subtract. So really, it's going to be 32 minus 16, and then you should be able to just say, whoa, now I know what the next step's going to be. It's going to be divide by 10. And that's going to equal your A, right? I would expect over three-quarters you to be able to do that one step. If you can't do it, work towards that. Okay, if you need to write it down in 2 steps, it's okay, but let's work towards this, okay? So that's going to be 32 minus 16 is 16 divided by 10, 1.6 meters per second squared. Feeling good about this?
Absolutely. That's so much faster.
Oh, yeah. You feel like you're an advanced mathematician, Riley, now that you know that stuff from yesterday? No? No? Part B says, what is its average speed? Now, we didn't come up with a new one yesterday with average speed. They all, in fact, have acceleration in them, right? So, I'm going to write V bar is equal to VI plus VF over 2. So that's going to be 16 plus 32 divided by 2. 16 and 32 is 48. Divided by 2, 24. Now, the reason that I do that is to show you one value or one use of those ones from yesterday. Because if I wanted to know how far it moved while accelerating, I could now go V bar equals D over T. 24 is equal to D. Conveniently, the T is 10, which makes our displacement equal to 240 meters. Now that is part C, right? I did it all in part B. That's kind of, like I said the other day, the country version of that. 2 steps. You could also avoid all of part B and do what? How would we get part C without doing V bar? Equation 2, Johnny?
Yeah.
Which says what?
E plus VI plus, or
VIT plus 1/2 AT squared. Because what we did yesterday was we kind of took these and we kind of mashed them together, right? We put the steps together into the formula, right? And now we can do it all in one step. And it's so much easier when you got a VI is 0, because that VIT just falls apart, right? VI is 0, then it's just like 0 times whatever, right? So that, but it's not the case here. So this is going to be 16 times 10 plus 1/2 our acceleration of 1.6 squared. And just for fun, I'm going to break that into 2 parts. I wouldn't normally do that, but I want to say something when I get to the end. So 1.6 squared, I don't think I can do that in my head. Maybe I can, hang on. Is it 2.56?
Yes, it is. You're missing the Jan. The 10.
Excellent. What would happen if you'd made that mistake on a test? Well, okay, so now 10 squared for sure I can do in my head. That's 100. 100 times 1.6? 160, and half of that? 80. See, you can do these in your head. You don't need to grab a calculator right away. Work at it, you'll get better. It's kind of like swimming term.
I have to randomly figure out, like, you can't just
Sure, 10 squared is 100 times 1.6? 160, half of that. Now go 160 plus 80 and guess what you get? 240, which is the same as that. I'm showing you what not to do. You don't need...
But yes, you do, because
B says that, right? But could this question have been done?
If there was no B, yes.
And that's my point. Okay? That's my point. Now I want to say this though too. What is the 160? Like, think about D equals VIT plus a half AT squared. Think of it this way, in sort of a visual kind of an understanding. Like, let's not just talk about the numbers. Let's try to understand. The VIT is the 16, which was the average speed, times 10, right? So in other words, if it was moving an average of 16 for 10 seconds, it would travel 160 meters. But it also did what? It accelerated, right? It started. I'm not sure how to go back here. It started at 16, right? If it stayed at 16, it would have gone 160. But it didn't stay at 16. It actually sped up. So it goes 160 and also another 80 because of the speeding up, the acceleration, right? And then you add those two together. Does that sort of visually, kind of understandably, kind of generically make sense? I hope so. Here's another really one in really small font. Let's make it bigger. Do you want to try this one on your own? Are you ready for that? No, not yet? Okay. Okay. A ball initially at rest rolls down a hill with an acceleration of 3.3 meters per second squared. Because it's going down a hill, it's not 9.8, right? If it accelerates for 7.5 seconds, how far will it move? Notice that you're going to have to do that. There's no average here. How far would it have moved if it had started at 4 meters per second rather than from rest? Okay, so what do we know? We know acceleration is 3.3. We know the time is 7.5, and we're asked for how far it moved. I don't know. Oh, it does also say what? Starts at rest. It doesn't give you that number. It says at rest, right? And there might be questions where it doesn't say at rest. It just makes you think, well, if they don't give me an initial speed, then I'm going to assume it's 0. Right? And that's a fairly safe assumption most of the time. So this seems to be leading me towards, again, D equals VIT plus 1/2 AT squared. When the VI is 0, things are nice, as I said earlier. You don't even need to worry about the time. 0 times whatever is going to be 0. Plus 1/2, the acceleration, 3.3. Time, now this time it's 7.5 squared. I don't know if I can do that. Okay, 75 squared? Like 58 something. Times 3.3, times a half. I can't do all that, Tali. Help me out. Actually, I think I have it here. 92.8? Well, I looked at my sheet that I worked out before. Mervyn probably did it previously. 92.8. And B just says, how far would it have moved if it had started at 4? So, what's the difference here? Put 4 in instead of 0, right? That's it. That's it. Make sure you don't square the first t. Too much squeak?
Yep.
Is that good? Pretty straightforward, right? Nothing sort of unusual. We're just kind of getting going here.
Oh, that means winter's coming.
Winter's coming, yeah. A boy sliding down the hill accelerates at 1.4. If he started from rest, oh, this one's different, Johnny. This one asks, in what distance would he reach a speed of 7? Doesn't ask how far he would go after a certain time. It says, how far in meters would it take to reach a speed of 7.0? So a little bit different, right? So our acceleration is 1.4.
VF would be
Started from rest. VI is 0. Riley's right. The VF is 7, and we're solving for D, distance. Do we need time? It just says find the distance. So which one has VF, VI, A, and D in it? Yeah, that last one. VF squared equals VI squared plus 2AD. How many people maybe couldn't sleep last night because they pulled out that big long fraction derivation and read through it and then you were asleep in no time? No? It is a good idea. I should try that myself. Seven squared, VI is 0. Okay, now the math here might be a little bit different. Come on, Johnny, stay with us now. Try to not to be distracted by the licorice.
Flint learners. Year one swap.
7 squared is 49. The 0 squared disappears. 2 times 1.4. 2.8d. Divide by 2.8. So you're going to get 49 divided by 2.8. I get 17.5. Sometimes the coach will say, why don't you try on your own and then let's observe.
Okay, but then show you how to do it first.
Well, I've shown you 3 times. It's okay to struggle here. It's okay to struggle. That's how you get better. I really have to get that box cleaned. Please give this a try while I go to attendance. Please give that a try. Johnny, refrain from playing with the licorice.
No narrating.
No narrating. It'll be like a silent movie, like back in the 1920s when I was a kid. You call me a clown? Hang on, I'm doing the silent treatment.
Why do you need to put it like that?
Why?
Why? It's already in meters per second. It doesn't tell us to put it. So I'm going to.
I don't know what's going on. There's a lot of whys going on here.
Why?
Oh, I know.
Why did you give us the hard spot? Why did you say? I still got that. I got the answer.
Hey, I got that too.
All right, so I heard a lot of whys, and that's awesome. And I purposely ignored you. The question doesn't say to put it in kilometers per hour. I realize that, but I thought it might be interesting to know just how fast that is in kilometers per hour. So I threw that in there, and I didn't have a calculator, so I was kind of hoping that if I just did that, maybe someone would type it in instead of going, why?
257.4.
How much?
257.4.
Well, that's not. You should have a jump as well. You should have a picture of something.
Hey, it did it.
Okay. So because I was curious. Okay, so let me go through it, and then maybe I'll answer some questions as I go through it, right?
I forgot to keep squares.
Okay, so we're going to use the VF squared equals VI squared plus 2AD. We're going to plug in what we know. It says, what is its speed upon takeoff? So that's one way of saying, what is the final velocity after that accelerating time period? Right? That's what they're trying to get at there. And it works out to 71.5 meters per second. And I was curious, so it happens to be 257 kilometers per hour. That's pretty fast, right?
You have a picture of something.
I have some news for you, Brett. In part B, it asks, what is the time required for takeoff? So I'm going to use the only one that has T. I can use this one. Actually, I could probably use VF equals VI plus AT, right? Could do that. Would you get the same value?
Yeah.
Of course you would. Right?
We did that.
The only real danger there is that if you made a mistake in getting your VF, that mistake might carry through, right? Whereas here, the 16, you're right. Good point. You're right. Good point. Does 44.7 seconds seem like a reasonable amount of time for a plane to take off?
Yes.
Everyone okay?
44 seconds.
I happen to be on 2 planes in the last few months, and both times the nerd in me went like this, because I knew that this question was coming up. And it varied anywhere from about 25 seconds to almost 45. And I got thinking to myself, why would this one be so much? I said to myself, I wonder why it's so much longer. Then I looked around and I realized, this plane is really full. When the plane is really full, that means there's more mass. Not only more people, but more luggage. Does it make more sense that if there's more mass, it would take longer to reach the takeoff speed? Right. Now, Brett made an interesting observation. He said, you got a jumbo jet there, Mr. Ben, a big plane. It should really be a smaller plane. Well, I just happened to be doing some Googling while you guys were doing that. And I can tell you that a runway of approximately 6,000 feet or 1,800 meters is usually adequate for aircraft weights below approximately 200,000 pounds. Larger aircraft, including wide bodies, usually require at least 2,400 meters at sea level and somewhat more at higher altitude. Why would it need to be more?
Air
Air is thinner, less lift, which means you actually got to be going faster. And the longest runway in the world, want to take a guess? How long is it?
5,000 meters.
18,000.
Over 5.5 kilometers long.
How many meters?
5,500.
What uses that?
And that is in the mountains of Tibet. That is pretty big. So some interesting little facts for you. Okay, my turn to be quiet. You've got time to work. You can do now pretty much anything in that package from yesterday. I would encourage you to, for those of you that were with it, and even those of you that weren't listening very close yesterday, let's just go through that package again. Okay? So the front page is just kind of like theory, thinking kind of questions. You should probably do them, right? I did say you can leave out 17 and 18, the graph ones. Okay? And then I said questions 1 to about 9 are like a grade 11 kind of review. They start out really, really, really easy. Okay? They get progressively harder. Like number 9 is rated at a 3, challenge level 3. Then when you get to number 10, then they become more 4-yes style problems. And everyone should try at some point, and that doesn't mean jump right to it. You should try number 15. Right?
Yep.
You should try number 15. You should also try number 20. Those are challenge ones. If you can do those, you're in good shape.
So can we start?
Don't start with them. Now we're going to put 500 pounds on the barbell and try to lift it. Work your way. Practice. You're going to have the whole period of work.
I don't have to more than
Yep. On Tuesday, remember no school Monday? On Tuesday, Johnny, you will need your textbook. We will look at some slightly different wording kind of questions. On Wednesday, we'll go into what I call the Fred and Barney style questions. Monday's our school, right? And then we got to get into vectors.
That's
Vectors.
That's your favorite probability.
Yep.